We're going to be going over the chain rule, which is note card 23. And these are just the various ways of writing the chain rule. So basically, the one that I like to use mainly is this one here, because it kind of gives you an example of taking the derivative of the outside, leaving the inside alone times the derivative of the inside. So this would be your inside, the derivative of the inside, leaving the inside alone, this is the derivative of the outside. Now these can be interchanged. So this one here and this one here. So you can write this one first, or you can write this one first. So it's really up to you. All right, so let's, this is just some examples that we're going to be going over. So if we take the derivative of this portion here, okay, based on this example, we have to have an outer function and an inner function. So here we have f and here we have g. So my outer function is the parentheses squared cubed, and my inner function is the x cubed plus 7. So I'm going to take the derivative of the inside. So it's going to get 3x squared, and then times the derivative of the outside. So I'm going to move this 3 to the front, so it's going to be 3 times the inside, leaving the inside alone, and then taking away 1 here, so it's going to be 2. So here, that's derivative. So technically that's a derivative, so we can basically simplify it just a little bit more. So 3 times 3 is 9, x squared, times x cubed plus 7 squared, okay? So that's the answer for that one right there, okay? Now number 2, it's a little funky because it kind of seems like it's going to be the quotient rule, but remember this can also be written as 1/5 cosecant of 3x, okay? So now you have your outer function of 1/5 cosecant, and your inner function is 3x. So when we take the derivative of the inside is 3 times the derivative of the outside, so it's going to be negative, so times negative 1/5 cosecant of 3x times cotangent of 3x. So remember, the derivative cosecant is cotangent, cotangent. So you just got to remember that you have to write the 3x in both of them, leaving the inside alone. Okay? So this is the answer, but when we multiply it out, we get negative 3/5 cosecant of 3x times cotangent of 3x. Okay? All right. Now this next one over here, we have the product rule actually. We have to rewrite this before we take the derivative. So it's the product rule. It's this function times this function here, okay? So when we take the derivative, it's going to be the derivative of the first, which is 1, times the second, plus the first times the derivative of the second, which requires us to use the chain rule. So it's chain rule within product. So here it's going to be times 1/2 times the original, and then taking away 1, which is 2 over 2, and taking away 1, you get 1/2. So 2 over 2, okay? Times the derivative of the inside, which is a 2. Okay, so all of this here, from here all the way to here, is the chain rule. So here I'm going to rewrite it. So I get 2x minus 3 to the 1/2, plus this 1/2 and this 2, they reduce to 1, so we're just left with x. And this is a negative, so I'm going to bring it down, and it's going to be the square root of 2x minus 3. Now I could have rewritten this, and just for the sake, because I don't have enough space, just know that you can actually rewrite this as the square root of 2x minus 3, just like I did on here. But this stays up top, okay? So that's the derivative. All right, now here we have y prime. It's going to be, once again, the product rule. So I'm going to take the derivative of the first, which is 2x, times sine 2x, plus rewrite the first, and then this is going to be chain rule because we have the sine as your outside function and 2x as your inside function. So the derivative of 2x is 2, so times 2. And then the derivative of the outside is cosine of 2x. Okay? So in rewriting this, we get 2x sine of 2x plus 2x squared cosine of 2x. Okay? All right. Now this last portion here, it says find the equation of the line to the tangent graph of tangent to the graph of f of x at point 1, -1. So if you want an equation of a line, you need a point, which is 1, -1, and a slope. So we have the point, we just don't have the slope. So we need to take the derivative to give us our point. So the derivative of this portion is also the product rule, but there's chain within it. So the derivative of x is 1 times the second, plus the first times the derivative of the second. So this is going to be chain. So the derivative of the inside is -2x, so times -2x. And then the derivative of the outside is going to be 3, so times 3, I hope you guys can see that. So it's times 3, and then rewriting the first 1 minus 2x, and then take away 1 is going to be a 2, and then we close it up. Okay, so all of this is the chain rule. So this is the derivative of the inside, which is negative 2x, and this is the derivative of the outside. So I had to bring this 3 to the front, so I brought it to the front, rewriting the inside, taking away 1. So here, I'm going to go ahead and plug in 1, okay, because that's the x value, and I want to find the derivative there. So I'm not going to go ahead and rearrange this any at all. So it's going to be 1 here. It's going to be negative 2 times 1 is negative 2. 1 minus 2 is negative 1. Negative 1 cubed is negative 1 again. So I'm going to write negative 1. So all of this here is negative 1. Plus, plug in a 1 here, that's just a 1. Plug in a 1 here, that's just a negative 2. 1 minus 2 is negative 1. 1 squared is 1. So all of this here is 1. 1 times 3 is 3. 3 times negative 2 is negative 6. Okay, so here we get negative 6. So we end up getting a negative 7. So my slope here is negative 7. So now we have enough information. So y plus 1 is equal to negative 7 times x minus 1. And that's it.